Morning, everyone. All right, so today we want to define what is an algorithm, explain two characteristics of an algorithm, and state two ways of representing algorithms. Well, we're really going to look on three. We also need to explain the sequence control structure and develop simple algorithms using sequence control structure. All right, so the problem solving process. All right, here we have on the screen is the steps in the problem solving process. Most persons would have had this already because we covered this in class, but we're going to review them just the same. So the first step, we have to identify our problem and define the problem. What this part is asking is specifically, what is it that you ought to do? What is it? What is the description of the problem? So you would look on finding the area of a square, um, calculate the GCT of a product, um, outline the steps that are necessary to bake a cake. So your identification and definition of the problem must be clear. Then you have your problem analysis. This is where your IPO chart comes into play. So you're going to identify your input, your output, your processing. Three, identification and evaluation of possible solutions. Now, one person, let's say Kamali. Kamali has a particular way of solving a problem. Let's say getting dressed for school on a daily basis. O'Brien is going to have a different method. It doesn't mean that Kamali's method is incorrect or O'Brien's method is incorrect. It simply means that there are different ways to solve it. When it comes to problem solving in the programming sphere now, you have to identify which one is best. So even though O'Brien's method is going to yield a solution and Kamali's method is going to yield a solution, which one is best? Which one is going to take less steps to give you the same output? All right. So after that, now you're going to justify why is it we're using this solution? Why is it we're using this method? Then you have to represent the most efficient solution as an algorithm. So you write your algorithm, then you're going to test and validate for correctness, and then translate into a program code. So what is an algorithm? So here we have the definition. Now key note, we have two words that are in bold. We have sequence. It is a step-by-step process. It's not a all-in-one thing. So you must remember that one, it is a sequence of instructions that are used to solve a problem in a finite amount of time. So the the algorithm must have an end point. It's not going to continue forever and ever and ever. Even though you have looping structures, it must have an end. So you can have a loop within an algorithm, but what will cause this program or solution to come to its end? An algorithm is not a computer language, which means that you cannot put it in a compiler and run it. It is going to give you multiple errors, and as such, it is just a step into the program development. Are we clear? So what are the characteristics now of an algorithm? Preciseness. So we said it is a sequence of steps, 5 steps, 10 steps, 11 steps. Some program probably have 100 in there. Or it must have a precise number of steps. It's unambiguous, which means that it is clear. So when you read it, you're not going to get multiple interpretations from it. It is 1 plus 1 equal 2. It is sum divided by 3. It is output average, it must be clear. It must give the correct solution in all cases. Um, so when we were in class the other day, um, let's say area of a square is not half base times height. So that would be incorrect. It wouldn't give the correct solution. Um, if it is that you're finding the average of 5 numbers, but you calculate average before you ask the users to enter the five numbers, then that is going to yield an incorrect solution or no solution at all. And as I said before, your algorithm must come to an end. All right. So we're looking on precision versus ambiguity. So a description is ambiguous if it is vague or has two or more meanings. Would have looked at this in class. A description is precise if it is strictly defined or definite. All right. Find the area.
Ambiguous.
It would huh?
Yeah, I have enough way to find the area, miss. That's one.
Exactly, and it's not telling you the area of what? Good. All right. Find the area of a square. It's no precise. Write a program which is going to accept the name and grade of a student and calculate the average. What's wrong with that?
Which student?
Repeat this.
All right, write a program which is going to accept the name and grade of a student and calculate the average.
You need to be more specific, miss.
Yeah, but which part of it would
Yeah,
need to be more
This,
specific?
this student.
the average part.
At the average part, is because the program's supposed to, any student information you enter Kamali, it's supposed to automatically do it. The problem is now you say a grade. Now if you accept a grade for a student and you're going to calculate the average for it, it wouldn't make any sense. So here we have some examples. All right, so it's a consider the following description: a tall person, a tall building, a tall flower. So each of this now is not precise. It's not precise because tall in itself is vague. Um, Tall to somebody like me, I am tall, but I am short when I am compared to taller persons. So in this case, no, you would need something else. Um, let's look on the precise. So it says a 6 foot tall person, a 4 story building, a 2 inch flower. Now that in itself is not ambiguous because I know how tall the person is, I know how tall the building is, I know it's 4 stories tall, a 2 inch flower or 2 inches, or a 6 foot tall person. All right, I get from one. All right, how do we represent an algorithm? So we have 3 ways. We have pseudocode, flowchart, and narrative. So the prefix pseudo means false. So hence a pseudocode is a dummy way of representing the solution to a problem using simple structured instructions. So it's going to mimic the. All right, so let us run back through certain things now. We're looking on problem solving. We're looking on how is it we go about solving a problem. Now, though persons are of this idea that this part is difficult, it is the same thing that you do on a daily basis. When you think about going to school, when you think about getting lunch, when you think about um, every aspect of your life, cooking, It is a step-by-step process. It is basically a problem that you're solving. You are hungry, that's a problem. How do you go about solving the problem? Is it that you're going to cook? Is it that you're going to search the fridge for food that's already cooked? It is a step-by-step process. Good? Now, in computing itself, there are multiple ways that you can represent the solution to a problem. And we're saying that one such way is a pseudocode. That's what's on your screen now. Now your pseudocode, and we said the prefix pseudo means false. So false means that it is not a computer language. That's the false part of it. So after writing your pseudocode, you can't put it in a compiler like Easy Pascal and compile it and not get an error because it does not follow the programming rules. Good? So that's the pseudocode part. All right, moving on now. So that's pseudocode, flowchart. Now, a flowchart is a pictorial way of representing an algorithm using a set of standard geometric shapes to represent actionable items. So today, right here, you will see a very simple flowchart. So you have different symbols that are used for different things, and we will go into that more than likely next week. All right. So here we have a note. When designing a solution algorithm, you need to keep in mind that computer will eventually perform the set of instructions. So you're writing the algorithm to transform that algorithm into a programming language, whether it is Pascal, C, Java, whatever it may be. So like here at the CSEC level where you're required to learn Pascal, when teaching the algorithm, what we do is that we use the same language or similar language to the Pascal so that when it is that you're ready to transfer the code or the algorithm now into a programming code, it is not difficult for you to do so. All right, so basic operations now. Your computer can receive data. This now is the input. This is the input aspect. You're going to take data from the outside world. You're going to take data from the user. So that is the data that you're going to receive. As an example, the area of a square, and I'm going to refer to that a lot. Area of a square. You're going to receive data. You need the length from the user. So you're not going to write an algorithm which is going to find the area of a square with the length always being 2. You want the user to enter any value and it's able to carry out that function. Then you have put out information. So it makes no sense for you to write an algorithm or a program and it's not going to output any data. That in itself wouldn't make much sense. At some point in time, it is going to output information to the user. So in the aspect of the area of a square, it's going to output area. It doesn't necessarily need to output the length and the width that the user entered. It's going to output the area. If I ask to calculate your GPA, I'm going to need the 8 subjects, the grades for the 8 subjects that you need, and then output the GPA. I need not output the 8 grades that I got. It's going to carry out some processing activity, arithmetic, some calculation will be done. Some assignment will be done, which means that we're going to tell the computer that this particular variable must be assigned to this value. In the same way, it kind of ties in with arithmetic, because when you have area equal length times width, you're basically telling the computer system to assign L multiplied by W, whatever values they are, and store it into area. Then now a computer can compare variables. Um, let's say we're going to assign letter grades. So for a person who has 80, those persons should get A. Persons who have 70, they should get B. So it is going to compare the grades that are given by the students or by the user and then assign a letter grade. And then it can repeat instructions, and we're going to look on that later on. So every algorithm should have the following sections. And we're going to have the sections just as so. If it is that you maintain this structure, you won't have a problem when you transition into program development. So we're going to maintain this at all costs, right? So the first thing you're going to have is your header. Your header now is going to give your algorithm's name or title, or your program name or title. So let's say area of a square, area of a triangle, finding average, school grading system, tax system, whatever it may be. You're going to give the name of your program so that anybody reading can know exactly what it is that it is supposed to do. Then you're going to have your declaration. Your declaration is the list of variables to be used in the program itself. What we find over the years is that when they list out the variables, is not the same variables that are used in the program. And I'll show you examples of that. And I'll show you how it is that we can correct that later on. But right now, we're focusing on the different sections. So you have your header, which is the name or title of your algorithm or program. Declaration, which is the list of variables to be used in the program. You have your body, which is normally signified using start and stop. Anything that falls within the start and stop, that's the body of your algorithm or program. And then your terminator. As we said before, your program must come to an end. All right, so algorithm structure. Algorithm structure. It is very important that students get the habit of writing properly structured algorithm at an early stage. Guys, try not to shy away from this aspect. You need to form your own interpretation of what algorithm and program development is. It is similar to math. You must practice. If it is that you don't practice, it's not going to just come to you like that. Once it is that you practice proper techniques and good structure, you will not have a problem. That much I can say, honestly. So if it is that we adhere to the structure above, transitioning into program development, the whole aspect of algorithm writing will not be difficult. All right, so let's look on variables now. What is a variable? So a variable is a named location in memory which stores data that may change during the execution of a program. Key part, because we're going to look on our next term, may change. May change during the execution of a program. Variables basically hold data. That's what you want to remember. It is going to hold the data that you are, one, accepting, two, storing, three, outputting. Good? For example, num1, a total number. Now your variable name can be anything. What we do recommend is that when it is that you're writing your algorithm or program, it is best to use variable names that will signify what the data is holding. So here, where we have num1, we know that it is holding probably the first number. Total amount is holding probably a calculation of different prices, whatever it may be. So try as best as possible to have your variable name signifying what your data is holding. Note here, um, a variable name cannot start with a number. So here at num1, you will not have one num. That would be incorrect. What again? So it cannot start with a number. It cannot use, should not be used to hold multiple data, sorry. What does that mean now? Let's say you're accepting 5 numbers. You can't have num1 holding all 5 numbers. All right, so let's look on constant. Now, constants, it just stand up in your life and not change, not moving. So this refers to a named location in memory that does not change during the execution of a program. And here we have 3 examples. Depending on what you're writing your algorithm or program for, your constant will be different. But common example, pi. Pi is equal to 2.147. So that's a constant. And the key part now is that it does not change. Now, if you notice, when we were looking on the variable, we said that a key part of that is that it changes during the execution of a program. The pi constant, does not change. So as your program runs multiple times, it will stay at whatever it is that you set it at. So pi 2.147, days equals 7, GCT 0.165. Now note guys, for algorithm, you can use the percentage sign. However, for program implementation, you cannot. So we don't use percentage sign in your program implementation. So if you have something that is given as a percentage, convert it to decimal and use the decimal. So if you're going to find 16.5% of the price of an item, once it is that you put in 16.5 and the percentage sign, you would get an error message. All right, so let's look on literals now. So we had 3 terms. We looked at variables, and we said that variables change during the execution of a program. You have constants. Constants don't change during the execution of a program. They will remain the same. And you have literal, literally. That is what it is. So this is where the name of the value, the name represents the value it is holding. So example, 50, the word 50 equal the number 50. Caljon equal Caljon. So that's the example there. All right, continuing guys. So let's look on a algorithm here. So writing a pseudocode for first 4 operations. All right, so the operations, which is to accept data, store data, caret and arithmetic, output data. All right, so first thing, we said that you must have your header. This part is the header section, finding average of 3 numbers. So this part now is going to tell what this algorithm is doing. So all it is doing is finding the average of 3 numbers. Here, we have our declaration. So we're listing the variables that we're going to use in this algorithm itself. So we have 4 variables, num1, and as we said before, if the 1 was at the front, it will be incorrect. So 1 num, 2 num, 3 num, wrong. Your variable name cannot start with a number. In the same way, your variable name cannot have a space. So if you have num space 1, when you transition into program implementation, it will give you problems there. So we don't have a space. We don't have spaces in our variable name, and we don't start it with a number. There are other rules, but they will come into play as we go along. So here we have 1, 2, 3, 4 variables. Num1, num2, num3, and average. Now this is what I was saying. Some persons will list 4 different variables here. And then when you come down into the algorithm, you find different variables. So here, whatever variables you have up here, they must be used in your program down here. So what some persons can do is that they can write the body part of the algorithm and then write out the variable names in the declaration section. Or if you find it easier to list your variable names and then use them in the program, that's fine. Num1, num2, num3. So this now, if the user enters 5, 10, 15, 5 will be stored in num1, 10 will be stored in num2, 15 will be stored in num3. Good? Then now, average will be used to store num1, the average of the 3 numbers. Good? So here, we're just telling what is it that we're accepting or what will be used to store. All right, so now, so this would be your title. This is your declaration. Moving on now to the body of the algorithm. The body of the algorithm must be enclosed within start and stop. Start and stop. So the body of the algorithm or program must be within start and stop. Good. That's the body. Here, we need to ask the user to enter the 3 numbers. So what we're going to use is the word write. You could use the word print, output, display. However, because we're going to transition into Pascal and Pascal only use write, we're going to stick to write itself in the algorithm so that the transition can be easier. However, you can use display, print, output along with write. Any of those 4 terms and it will be correct. So once you put the word write, it means that this should be displayed to your screen. So here we're saying to the user now, enter 3 numbers. So this will come up when we transition into program development. What you will see on the screen, enter 3 numbers. Good? That's this part. This part now, we're telling the computer system itself, and this is an error right here because there should be no space. So we're telling the system now, the first number that the user enter should be stored in num1. The second number that the user enter should be stored in num2. The third number that the user enter should be stored in num3. Good? After having these numbers stored in the variables, we're going to calculate average. Right. So average, what is the formula for average? Average is equal to num1 plus num2 plus num3 divided by 3, the same amount of numbers. So if it was 4, this would be 4. And then the last part now is to print average. So encased here, we could have this. I'll show you. So any of the two could work. Whatever we have in quotation, those are texts that we want to be displayed on the screen. This part here, AVG, whatever value is stored in it, that is what will be displayed on the screen. So let's say the user entered 5, 10, 15. 5 plus 10 is 15. 15 plus 15 is 30. That is what would happen here. So 30 would be added. 30 divided by 3 is 10. So what would come up on the screen based on this is the average is 10. You wouldn't see the word AVG because it's not in quotation. Once it's not in quotation, it is going to display whatever value is stored in that variable. All right, so let's look on this example now. So a program is required to prompt for the maximum and minimum temperature readings on a particular day. Accept those readings as integers and calculate and display the average temperature. Create an IPO chart and a pseudocode for the above program. All right. So here we have the IPO chart. So what do we want from the user? That will come under input. So here we want the maximum temperature and the minimum temperature. Let's go back. See? It says it's required to prompt. Once it's a prompt, it means that we are going to ask the user for it or use the word input. So that's this part. All right, maximum and minimum temperature readings on a particular day. Accept those readings, which means that we're going to store them into variables. And we need to calculate and output, same thing as display, the average temperature. All right, so let's go back. So here we need from the user max temperature, minimum temperature. And that's my variable name for those two, right? You could have MT, MXT, MIMT. You can choose whichever variable name you wish to choose. What is our processing? So we're going to ask the user to enter the temperatures, store them in the variable names, calculate temperature, and then output it to the screen. Guys, remember that everything that you do is classified as processing. Hence, we put it under the processing column. What is it we're going to output? We're going to output average. All right? All right, so look at that. So moving on now. Post your questions in the chat if you have any. All right, moving on. All right, so let's look now on the solution. So we said we must have our name. So we're going to find this algorithm is being used to find average temperature. That's the name there. Must be at the top. Yes, yes, Jose. Every single step. All right, so as we said before, name of our program or algorithm, declaration, where we list the variable names that we're using. So here we have 3. Max for the maximum temperature, minimum temperature, and average temperature. Right. So here we move to the body of the program. Again, the body must be enclosed within start and stop. We use the word write, which means that it is an output. We want this to output to the screen. What will be displayed on the screen? Enter, max, and min temperature. You could break this into two. You could have one where you have enter maximum temperature, read max temp. Then you would have again write, enter minimum temperature, read min temp. So you don't have to group it together. You can break it if you so desire. Then or calculation. Average temp equal max plus, sorry, this there should be a plus sign. Let me put that there. Plus sign. That should be a plus sign, guys. Anyway, so max temp plus min temp divided by 2. That is our processing here, or arithmetic. So we're assigning whatever is on this side, which is the calculation part, and we're assigning whatever value we get at the end into average temp. Here, we're going to print average temp. And again, as I said, instead of that, for me, what I prefer is this. So you're going to have print, open bracket, quotation, average temperature. All right. So that's that part. And then we have our stop. All right. Somebody highlight what is it that we're accepting? What is it we're to accept from the user? Or just draw a line underneath it.
The formula length and width.
All right, length and width. Oh, you know, select what is it we're calculating?
Length times width.
No. What it is?
What then? Length and width. The area of a rectangular house back.
No.
Mowing time.
Thank you. It says should can compute more. All right, so IPO chart. Output. All right, good. So let's look now. So under input, we need from the user the length. No, notice this is not one thing. It's actually two things. So we need length of house and we need the width of the house. So I'm going to have LH, LW. Length of the house, no, WH, width of the house. All right. Then now, hold on there. Length and width of rectangular house block. Then you want the length and width of rectangular house build. All right. So I'm going to put LL, so that's for the land, and WL, that's for the first part. So this will be for the house, this will be for the land itself. So right here, what it is asking you is for the land itself, the length and width of the land. Then you're going to take the length and width of the house. All right, so Shakil, this length of house, width of house, length of the land, width of the land. That's what we have there. All right, ready. So let me insert a table. All right. Table, 3 columns. All right, let's work from this. So we have input, starting over, processing, output. All right, good. We're going to have, as we said before, we have the length of the house, length of the house, width of the house, length of the land, and width of the land. Good. So over in our processing, we're going to read LH, WH, LL, and WL. So this means that we're going to take it from the user and store it in this here, right here. Good? So that's that part. Let's look on the processing now. So it's the calculation, sorry. It says the pseudocode should then compute and display mowing time. So that's what we're going to do. So we're going to compute. We're going to compute mowing time. And then we're going to output mowing time. Soon take your questions. All right. And then that will go on the output again. But that's what we're doing. The calculations part is done in the IPO chart, in the processing section of the IPO chart, Colin. Here the thing. All right, so I'm assuming that the mic is better now. All right, ready, guys. All right, so Colin, listen. Right here where we have compute mowing time, you have the option of writing just that, or what you can do is show the actual calculations that you will be doing. Whichever part you do right there, it's fine. So there's no rule which says that you must, but once if you write calculate, that's fine. Otherwise, everything good. All right, so last part, let's write the algorithm, and then we are out of here. All right, moving on to the algorithm. So we said the first part that you're supposed to have is what is it that the algorithm is doing. So here, and I'm going to move in between screens. So here, the algorithm is supposed to be used to calculate mowing time. So that's what we're going to write first. Calculate mowing time. All right, then now we have our declaration. How many variables do we need? All right, no problem.
Let me know when you finish. Oh, the table too. Okay. 4, Shaquille. No, you actually need more than that. The 4 will be for the input. Shaquille just, I guess, Ben says 6. All right, let's go. Let's try and figure this part out. So we know we have 4 data that we wish to accept from our user. So we have the length of the house, we have the width of the house, we have the length of the land, and we have the width of the land. For us to calculate the mowing time, and we need to calculate mowing time, we're going to break it up. So we need area of the house, and we need area of the land. If there's any more, we'll come back. So right now that's 2, 4, 6, 7. So Shaquille said 6. That's close, but 12 did far off. Right, 7. Okay. All right, moving on now. So we're moving on to the body, and we said that the body must be enclosed within start and stop, and then we indent away from stop, from start and stop. So the body will be indented. All right. So first, we need to ask the user to enter the data, and we said that we use write, right? So that when it is that we are ready to transition into Pascal, it will be easier for you. All right, so write. Enter length and width of house. All right, then now we need to store it in the variables. So we have read, and we're going to have length of house, width of house. Are we following? Then now we need to ask them for the length and width of the land. So let me just copy this and use that. So instead of house here, this will be land. And this now will be LL. And what we did have up here? So is it WL? WL. Now watch me go on, I need to write up at the top. All right. So we have enter, we have the length and width of the house, we have the length and width of the land. All right, so that's what we need from the user. Let's move to our calculation. So mowing time now. We're not area first. Area of the house will be equal to LH times WH. Area of the land is equal to LL times WL, width of land. Then now mowing time. Let's go back to the question for a quick second. So this part here, it says compute and display the mowing time required to cut the grass at the rate of 2 square meters per minute. All right, so mowing time now. How do we calculate mowing time? Based on this. So we have area of house, area of land. And it did say now that the mowing time, this part here, mowing time at a rate of 2 square meters per minute. What is it we're going to have here as the calculation? Mowing time is how long you going to take to cut the grass around the house? Yes, you can put in all the variables at once, Brown. That's what we did. However, if as you go through you realize that you missed, then you can add. Divide it. What's it? One, what's it? Give me the full calculation. The division by 2 is fine, but it's incomplete. I'm asking, how is it we're going to calculate the mowing time? If it is that they want to know, how is it that you would cut it? Divided by rate. Find the average bent? No. All right, first thing. No, Javon, you wouldn't add. You wouldn't add the area of the land and the area of that. You wouldn't add it. How you get 60, Jackson? Remember that you're using whatever value the user give you, know. All right, Javon's response is the best. Thus far, it is incorrect, but let's use that one. So his own is AL plus area of house subtracted from area of land divided by 2 meters. Yay, Chandra. So Chandra's answer is the correct one. All right, so let's write that now. So now, mowing time, which is MT. All right, so mowing time is equal now to AH minus, hold on, area of land minus area of house. And then we look back on correct calculation. If it is that you had area of house minus area of land, you would have received a negative figure, and then that in itself would be incorrect. So it wouldn't yield the correct output. So we have to be mindful of that. All right, so let's output mowing time now. So we'd have right, open bracket, quotation, mowing time is, and remember whatever we have in quotations, that is what that text will be displayed, but empty now, the value will be displayed there, and then you have stop, and that would be the algorithm there. So let's take the final set of questions, and then we will sign out, and then Monday I'll see you guys again. Space which output? A space after is? Dalan, a space after is, yes. Yeah, a space should be there. Otherwise it going to merge. It going to look like one with no space between it. Why did you subtract? All right, this is what the question is asking, Javon. We're calculating, let's say, where you live. You're calculating the time it's going to take you to cut the grass. So the land itself, good? The entire land without the house. That's what we calculated the area of. Then we had the area of the house. The area of the land itself, if we were supposed to use that, it would signify that that is the entire land that you have to mow, but you have the house on it. So you have to calculate, you have to subtract the plot on which the house is sitting, so that you can get the area which you will be mowing or which you'll be cutting.